So we have one more reaction that is left, and that is your reduction reaction. So in the oxidation reaction, we used this O to represent an oxygen atom from the oxidizing agent. But in the reducing reaction, in the reduction reaction, we use this H in the square brackets. Okay, so it describes your reduction reaction. It means it is a hydrogen atom from the any reducing agent. We have written 2 here in the front of this to balance the equation for hydrogen atom. So this is what? This is my CH3, C double bond O, CH3. CH3, C double bond O, CH3. That means it is my ketone. So when it reduced, it gets converted into alcohol. So ketone gets converted to alcohol. So this is this H. It comes from the sodium tetrahydroborate, which is NaBH4, which is the reducing agent. Okay, write it down. Just I'm coming in. So here your ketone is reduced to your alcohol in the presence of NaBH4.
I'm done. I'm done.
Now I have told you some, I think 6 or 7 types of reactions. Now you have to identify these reactions, choosing from the type of reactions described above. So this is your homework question. You have to identify the reactions using the reactions which we have discussed. So there are 5 questions. Let's summarize this chapter, what we have studied from the very beginning. We have represented the organic molecules by empirical formula, molecular formula, structural formula, distillate formula, and 3D distillate formula. So you should know how to write down the formula in all of these forms. Next, what is functional group? It gives organic compounds. They are characteristic reactions. Okay, it is an atom or group of atoms which gives the organic compounds its chemical properties. Some of the important functional groups are alkene, alcohols, halogenoalkanes. So I have shown you the table of these general formula: aldehyde, ketones, carboxylic acid, esters, amines, and nitrites. So you have to remember that table, their general formula, their structure. Shapes of organic molecules, it can be explained by sigma and pi bond between carbon atoms. I told you that if there is one single bond, then it is a sigma bond. If there is a double bond, then it is one sigma, one pi. If there is a triple bond, then it is one sigma and two pi. Okay. There are two and hybridization also. So if there is a single bond, carbon atoms are arranged by 4 single bonds. It is sp3. If there is the presence of one double bond, so it is sp2, and if there is a presence of a triple bond, then it is your sp hybridized carbon. Then we have discussed isomers, 2 types of isomers, structural and stereoisomers. Okay. Structural isomers have same molecular formula, different structural formula. So types of structural formulas we have studied: position isomers, where there is a difference in the position of your functional group; functional group, where the functional group itself changes; or the chain isomers, where the root chain changes. Okay, it goes in branching. Next, we have studied about the stereoisomers. So they have same molecular formula, but they have different arrangement of atoms in their space. So there are 2 types of stereoisomers: geometrical, which is also known as cis-trans isomers. Okay, it arises because of the restricted rotation about a CC double bond. So I told you that CC double bond, it is restricted; you cannot rotate it. Otherwise, CC single bond is, we can rotate it. Optical isomers, it contain a chiral center. Chiral center means a carbon atom which is bonded to 4 different atoms. It is a chiral center. So it results in mirror images of the molecule that cannot be superimposed, which are also known as enantiomer. So we have discussed these things. Okay. So let us do some practice questions based on this. Which one of the following compounds does not need any number in its name? Okay, any number means write down the IUPAC name of all these compounds and tell me that which one of these compounds it doesn't have any number in its name. Solve it and then tell me the answer. So there's a misprinting, I think, in this question. You have to tell me the IUPAC name of these compounds. Okay. So in the first compound, you have CH3, CH double bond, CH, CH3. So what should be its IUPAC name? Then this IUPAC name and this. So I suggest you to draw the displayed formula and then tell me the IUPAC.
Hey students! Interested in boosting your studies? Enroll now at Keddy Edtech. We offer online tuition for the Cambridge curriculum, grades 6 to IGCSE, AS, and A-level. Start learning with us today.
I'm not sure, but I think it's A. I'm not sure, but I think it's A.
Tell me the UPSC name of A.
Butte 2 in.
Okay.
But I think because it's symmetrical, you don't have to say the 2.
But it is what?
Symmetrical. The double bond.
Yes, it is symmetrical. Okay. It is correct, Butte to win. What is the UPSC name of second B part? B part, Shama. Write down the discrete formula of B part. It is CH3, C double bond O, CH2, CH3. The counting starts from right or left? Shama, I'm asking to you.
Left.
Yes. 1, 2, 3, 4. So which functional group is this?
Ketone.
Yes. So it should be, what is the UPSC name? At the second position, you have ketonic group. So it is 2. And what is the root word?
Butte.
For ketone, we write in the suffix as
On.
so it is 2-butanol. Okay, very good. Alicia, tell me the answer of C part. Now, what is the UPSC name of this C compound?
2-bromobutane.
Very good. It is 2-bromobutane. Okay, because counting will start from where the functional group is nearest. 1, 2, 3, 4. 2-bromo and butane. Yes, Shama, tell me the IUPAC name of D part.
1,3-dichlorobutane.
1,3-di. Yes, correct. Because the counting will start from here. 1, 2, 3, 4. So it is 1, 3 dichlorobutane. Very good. So question is that which one of the following compound does not need any number in its name? Okay. So this also need a number. This also need a number. This also need a number. So the appropriate answer is A because it is symmetrical. So we can write it as butene also. Okay. So the answer is A part in this question. It is symmetrical. That's why only. So the second question says that which one of the molecules below contains the chiral center? What is the chiral center? A carbon atom where 4 different groups are attached. A carbon atom where 4 different groups are attached is called a chiral carbon. So from A, B, C and D, look and tell me which compound contains a chiral center. 4 different groups are attached to the carbon. You need not even have to solve this. You can answer it by seeing the molecule.
Maybe C. Is it C?
Okay. And what is your answer, Shama?
I think it's C.
Yes, it is C. It is. You should be confident about your answer because this A part you can see it is symmetrical. B part is also symmetrical. D part is also symmetrical. So the answer is C only. And you can see this is the carbon where one methyl group is attached and one CH2 group is attached. One hydrogen is attached. 3 different groups and one CH2 CH, CHO is attached. So this carbon have 4 different groups. So this is the chiral center. So C part is the chiral center. It is correct. So this one is also your homework question. Write it down. Methyl propane is commonly used in the petrochemical industry. Name the homologous series that methyl propane belongs to. Okay. Homologous series we have already studied, alkane. Give the molecular formula of methyl propane, empirical formula, discrete formula, skeletal formula. You have to write all these formulas for methyl propane. So you have to do it in your homework. Note it down.
I'm done.
Solve it now. That each carbon in methyl propane has hybridized atomic orbitals. Which type of hybridization is found in a molecule of methyl propane? Which option should be correct? Solve and tell me the answer. Tell me the answer.
Is it C?
Yes, of course, it is CsP3 hybridization, because as I told you that if there are 4 sigma bonds, then it is sp3 hybridization. So methyl propane is CH3, CH, CH3, propane, and methyl group is there. So it is your methyl propane. So the carbon atom, you can see this carbon atom is also having 4 sigma bonds. This is also having 4 sigma bonds, 1, 2, 3, and 1 of this hydrogen. This also having 4 sigma bonds, 1 and 3 from hydrogen. So if you have 4 sigma bonds, then it is your sp3 hybridization. 1 from s orbital and 3 from p orbital. 1 plus 3 is equal to 4. So the answer is sp3 hybridization. Okay, next question. A carbon compound P has a percentage composition 85.7% carbon is there, 14.3% hydrogen is there. Okay. Its relative molecular mass was found to be 56. Tell me the empirical formula and the molecular formula.
Empirical formula, I got CH2. And for the molecular formula, I got C4H8.
Empirical formula, you got CH2. And for molecular formula, you got C4H8. Let's wait for Shama's answer, then we'll discuss.
Empirical formula, I got CH2, and molecular, I got C4H8.
Okay, so if both of you are getting the same answer, then it should be correct. But let me just again check the answer. So first of all, we have to calculate number of moles of carbon. 85.7 divided by 12. It comes out to be 7.14. And for hydrogen, it is 14.3 divided by 1, which comes out to be 14.3. Next, we have to divide it by the smallest number, 7.14 divided by 7.14. 14.3 divided by 7.14. So here it comes out to be 1 and here it comes out to be 2. Yes, so the empirical formula is correct. CH2. Empirical formula is CH2. Then we have to calculate the empirical formula mass. So to calculate the empirical formula mass, it is equal to 12 for carbon plus 2 for hydrogen. 1 for hydrogen, and since there are 2 atoms of hydrogen, so we'll write this. 12 plus 2 is equal to 40 grams per mole. This is the empirical formula mass. Then you have to calculate the value of N or X, which is equal to molecular mass divided by empirical formula mass. Right. So the molecular mass you are getting, molecular mass is given in the question, 56, and empirical formula mass is your 14. So 56 divided by 14 is equal to 4. Okay. Then to calculate the molecular formula, it is equal to empirical formula multiplied by N. So empirical formula is CH2. You have to multiply it with 4. So it comes out to be C4H8. Yes. So it is also correct. Empirical formula is also correct and molecular formula is also correct. So these are some practice questions of this chapter. So in the next class, what do you want me to do? Should I make you revise the entire chapter by practicing some questions, or should I start with the next chapter?